Hello, ladies and gentlemen. This is lesson 139, adding probabilities. So we've been talking about the probability of event A happening and the probability of event B happening, but we need to talk about what happens when we're having A and B happening or A or B happening. And we'll take a look at that with a simple Venn diagram. So let's consider this spinner here where it has evens and it has primes. The spinner goes 1 to 8, and it has two categories. The event A is evens, and the even numbers here, of course, would be 2, 4, 6, and 8. And then it says primes. Well, the prime numbers would be 2, 3, 5, and 7. So yeah, but 2 falls right there in the middle because 2 falls in both. The 5, the 3, and the 7 go over here, and the 8, the 4, and the 6 go over here. The 8, the 4, and the 6 are unique to event A. The 5, the 3, and the 7 are unique to set B. And the 2 itself actually just lives in the middle of them and where it's shared. And of course, 1 lives on the outside because 1 is definitely not even and 1 is not prime. So we're talking about the union and the intersection. The union, which looks like a U, right, is and. Union, and, they're together. Now you notice it looks like they cut the middle out. That middle's there, but you have to make sure you only count it once. The intersection, which looks like an upside down U, is that middle. Okay, it's the stuff in the middle. All right, so A or B is the union, right? So when we're talking about A or B is the union, what we have here is A or B is going to give me 2, 3, 4, 5, 6, 7, and 8. The intersection, A and B, is going to give me just the 2. Oops, 2. Okay? So how come A or B, the event A or B is not just the same as A plus B generally? I mean, it could be, but in general it's not. Well, we know that for A, you had 4 terms that work there. And for B, you had 4 terms that work there. But A or B, you only had 7 terms. Because the 2, the number 2, is in the intersection of A and B. And because it's an intersection, anytime you have something in the intersection, the only time A or the event A or B is equal to A plus the event B, the number of times it occurs, is when the intersection is empty. Our intersection is not empty, thus we don't have a situation where it's exactly the same. So a two-way frequency table, now you did talk about this back in Algebra 1, but we're going to talk about it here again, shows events or sets that can be combined for a union or overlap into the intersection. So let's look here. It says a small high school surveyed 52 of its seniors about its plans for graduation. And they found that the data that's here. Now they're going to M for male, F for female, C for going to college, N for not going to college. And you can see it's all cross-referenced, rows and columns. So how many fall into the M category? Well, M total is 30. F total is 22. I'm getting those numbers right from here. The 52 here is the total for the whole thing. C total is 29. N total is 23. Now, those are the very straightforward, just all going to the colleges, not college, male, female, etc. Now, let's talk some ands. So, if it's both male and going to college, that's right here at 16. Female and going to college is going to be the 13. Why? Because that's where the row and column meet each other. Now, let's be careful. This one is the or. So, it's F or C. Well, F is 22. That's how many females we have. The C is 29. But there's 13 that hit both of those categories. So it's 13 that overlapped minus 13 That equals 38. That's a 3. Now, what's the probability that a person picked at random would be a female who was going to college? Well, females going to college were 13 out of the 52, or 0.25, it's 1/4. That's different than when you said, what's the probability of picking a female or someone who's going to college? That's that 38 people we just were talking about out of the 52. And that comes out to be roughly 0.73. There we go. So in general, you have to make sure, what we're trying to do here is in general, how come this works? Okay, well, probably P of F, right? F was going to be 22 out of 52. And P of C ends up being 29 out of 52. And we know that P of F or C ends up being what we just are talking about. That's going to be the or statement, right? So you have to get rid of the and, so that's going to be the 38 out of 52. Fill in the probability in general to talk about this law, okay? So in general, P of A plus P of B minus P of A and B. Remember, that's and. All right? So sometimes you can do it like this. Sometimes we just have to run into just probabilities. When we're talking about creating here a six-sided die, or not creating a six-sided, we have a question here with a six-sided die being rolled. Sometimes we need to just kind of draw Venn diagrams. So they're talking about the events being probably of a number rolled was either an even or a multiple of 3. So these are the evens, and this is the multiple of 3. Well, 6 is both even and a multiple of 3, so it's going to live in the intersection. Now, if you think about it, what else is an even number on a six-sided die? 2 and 4. What else is a multiple of 3? It's 3. 1 and 5 live out here because they're not part of the actual event. So what they're saying is that you're looking for the probability of even or a multiple. Okay? Well, the probability of even, right? And the probability, so it's going to be what's going to work to be of this 1, 2, 3, 4 items work out of 6. You don't, because it's 1, 2, 3, 4 total items. You don't count 1, 2, 3 even, 1, 2 multiple. You're counting the 6 twice. You just count it once. Okay? Then it says, even though we don't need it, verify the okay. So we want you to prove this rule here. So you would say the probability of E is going to be 3/6. The probability of M is going to be 2/6. The probability of E and M, is 1/6. 3/6 plus 2/6 is 5/6 minus 1/6 is 4/6. We're done. All right. Now, sometimes you can't get around it. Sometimes you have to go with the actual rule, and the of just actually trying to multiply things or add things together. Excuse me. This says an insurance company has 56% of its customers have car insurance, 48 have home insurance, and 18 have both. That 18% is part of that 56, and it's part of that 48. It's in there twice. Find the probability that he or she picking one has at least one policy. So what it's looking like here is you're going to have the probability that they have a car insurance, okay, and that's 0.56. Probability that they have home insurance, that's 0.48. And the probability of C and H is going to be 0.18. So what you do is 0.56 plus 0.48 minus 0.18, and you get 0.86. The probability that they have one or the other is at least 0.86, because we don't want to count that 18 twice. It's counted in both, we take it out. Now, What's the probability they have neither? Okay, neither. So all your neither really means is 1 minus, it's 1 minus the probability of C or H. Right? Well, we already know that. 1 minus 0.86 is going to be 0.14, and that's the probability that they have neither. So that means because you're doing 1 minus, because 1 meaning the everything, all of them, people who have it and don't have it, minus the people who do have it at 0.86, leaves you with a 0.14 for people who don't have it. All right, folks, so that about does it for this lesson. If you have questions, please make sure you ask them next time we meet. Have a great rest of your day.